Lesson 4. Assignment Statements. Purpose of this lesson. In the previous two lessons, we wrote programs that displayed the results of calculations. We used variables to enable our programs to input values from the keyboard and work with those values instead of just doing calculations on literal values. In this lesson, we see how we can store the result of a calculation in a variable. This is done with a so-called assignment statement. Write a program to add 2 periods of time, example length is tracked on a CD. Each time must be inputs as a number of minutes and seconds. The output must be the sum of the two input times and must also be in the form of minutes and seconds. Test yourself. You should be able to write a program for this problem with the knowledge you have so far. Think about it. You can input 4 integers, minutes and seconds for the first period of time and minutes and seconds for the second. To add them together, add the minutes and add the seconds separately. The only complication is if the total number of seconds is greater than 60, in which case the total number of minutes needs to be incremented by 1, and the total number of seconds decremented by 60. This sounds complicated, but it can be done quite easily with the divide by and modulator operators. You should be aware, however, that things are going to get quite messy. The expressions for the total number of minutes and seconds are going to be long and complicated. What we need is a way to store the result of intermediate calculations so that we use them in further expressions to make them simpler. Write a program for the main activity, but ignore the problem of the seconds adding up to more than 60. In other words, the program can give the following input. Specify only minutes and seconds separated by spaces. Enter period of time 1, 35. Enter another 1, 2, 27. Total time is 3 minutes and 62 seconds. Add 2 times, specified as minutes and seconds, first attempt. Include IO stream using namespace std. Int main, int minutes 1, minutes 2, seconds 1, seconds 2. Cout. Specify only minutes and seconds separated by spaces. End L. Cout, enter a period of time. Cin, minutes 1, secs 1. Cout, enter another one. Cin, minutes 2, secs 2. Cout, the total time is minutes 1, minutes 2, plus minutes 2, minutes. Cout and secs 1, secs 2, seconds. End L. Return 0. This is the first time we've used metric characters, digits, in the names of variables. Variables min1 and min2 store the same kind of values, so we use the same name but with a digit attached to distinguish them from one another. The same goes for sex1 and sex2. Subactivity 4AII. Once you've got the above program to work correctly, edit as follows. Declare an additional variable called total mins. Add it to the declaration in line 7. Replace the expressions min1 plus min2 in line 14 with total mins. Insert the assignment statement total mins equals mins1 plus mins2 between lines 13 and 14. Compile and run the program again. It should do exactly the same thing as the first version. Discuss. An assignment statement is used to store the result of a calculation in a variable. In this case, the value of the expression mins1 plus mins2 is calculated and assigned to, in other words, stored in variable total mins. The equal sign is called the assignment operator. We place a variable on the left-hand side of the assignment operator and an expression on the right-hand side. Note that we cannot place an expression on the left-hand side because the computer cannot store a value in an expression. We can indicate the change that the assignment statement causes on the values of the variables by 2 sets of variable diagrams. Line 13. Mins1, mins2, sex1, sex2, total mins. 1, 2, 35, 27. After the assignment statement, the situation will change as follows. Line 14, mins1, 1. Mins2, 2. Sex1, 35. Sex2, 27. Total minutes, 3. Do the same for the remaining expression in the last output statement. Compile and run your program to test whether it still does the same thing as the original program. Your program should now look like this. Add 2 times, specified as minutes and seconds, second attempt. Include IO stream using namespace std. Int main, int mins1, mins2, sec1, sec2, total mins, total secs. Cout, specify only minutes and seconds separated by spaces, end L. Cout, enter period of time, cin, mins1, secs. Cout, enter another one, cin, mins2, secs2, total mins, mins1 plus mins2, total secs, sec1 plus secs2. Cout, the total time is total mins, minutes. Cout and total secs, seconds, end L, return 0. Discussion. In these sub-activities, we've seen that we can always introduce a variable to the program without changing the program's functionality. We often do this to store the value of a calculation for use later in the program. In fact, it's better not to calculate the value of an expression in an output statement as we have been doing up to now. It's better to separate processing, in other words, calculating the values of expressions, from inputting and outputting. To separate processing from outputting, it's often necessary to introduce one or more additional variables. Now write a program to input a large number of seconds. It could be 60 or more, and to display the time as a number of minutes and seconds. Use divide by and modulator operator. Convert a large number of seconds to minutes and seconds. Include iostream using namespace std. Int main, int secs, total minutes, total secs. Cout, enter a large number of seconds. Cin, secs, total mins equals secs, divided by 60, total secs equals secs, divided by, modulator operator 60. Cout, this is total mins, minutes. Cout and total secs, seconds, end L. Return 0. If you only use one variable in your program and included expressions in your output statements instead of introducing new variables, that was naughty of you. From now on, remember to introduce variables to avoid having to include expressions in output statements. You should now be able to write the program for the main activity by combining the ideas from the above sub-activities. The final program looks like this. Adds 2 times, specified as minutes and seconds. Final version, include iostream using namespace std. Int main, int minutes, int mins 1, mins 2, secs 1, secs 2, total minutes, total seconds. Cout, specify only minutes and seconds separated by spaces, end L. Cout, enter a period of time, cin, mins 1, secs 1. Cout, enter another one, cin, mins 2, secs 2. Total minutes, total mins 1 plus mins 2 plus bracket. Says 1, says 2, close bracket, 60. Total secs, says 1 plus says 2, modulator operator 60. Cout, the total time is total minutes, minutes. Cout and total secs, seconds, end L. Return 0. Discussion. You might well have introduced another variable for this program. Say many secs and use it to store the value of ses1, ses plus ses2. This would save having to calculate ses1 plus ses2 twice. So, this is another reason for introducing an additional variable to a program, to store the value of a calculation to save having to perform the calculation more than once. As you can see, one can't make hard and fast rules about what variables to introduce. All that you can do is apply the principle of making your code as readable or understandable and efficient as possible. There are a number of other assignment operators in C++, namely, explain what each of them does. Test yourself. To investigate these operators, write a short program that uses one or more of them. Note that they are assignment operators. This should give you a clue as to how to use them. The first sub-activity is an example of using this operator. The next two sub-activities are examples of using operator, which, like, works differently. Sub-activity 4bi. Write a program that first inputs a number from the keyboard into a variable called n, and then has this assignment statement n plus equals 27. The program should then output the value of n. Sub-activity solution. Test compound assignment statements, include iostream using namespace std, int main, int n, cout, enter a number, cin, n, n plus equals 27. See out. Now the value of the number is n in line, return 0. Discussion. From the output of this program, you should be able to see that the operator adds the value on the right side to the variable on the left hand side. Note that the value on the right hand side can be a literal, a variable, or a more complicated expression. Subactivity 4.bii. Edit the program you wrote for the previous subactivity and replace the assignment statement with the statement. Before you compile and run the program, try to predict the output. Discussion. The plus plus operator simply increments a variable by 1. Note the plus plus operator can only be applied to a variable and not to a literal value or an expression. As you can see, the plus plus operator is a unary operator in that it only operates on a single variable. All other operators we have seen so far are binary operators because they're always used with, in other words, between two values. You do know of one other unary operator, namely unary dash. The expression dash I gives the value stored in I with a change sign. In other words, if I is positive, dash I is negative. And if I is negative, dash I is positive. Note that the unary minus is only fixed in prefix form. In other words, it's always placed before the value it operates on. We use the postfix form of plus plus above. In other words, we place it after the variable it operates on. However, plus plus can also be used in prefix form. Try it now. Edit the program and replace n plus plus with plus plus n. The pre and postfix forms of the plus plus operator appear to do the same thing. To see the difference, do the next subactivity. Predict what the output of the following program will be. Tests unary increment operator, include IO stream using namespace std, int main, int mn, cout, enter a number, cin, n, m equals n plus plus, cout, m is m, and n is n, end L, return 0. Now replace n plus plus with plus plus n and predict the output of a program. Compile and run the program to check whether your predictions were correct. Discussion. Before we discuss the difference between the prefix and post forms of plus plus, note that we use n plus plus as an expression rather than a statement on its own, as we did in the previous subactivity. We can do this because apart from incrementing a variable, the operation returns a value. In other words, the variable together with the operator can act as an expression. The value that it returns depends on where the operator is placed. If it is used in its postfix form, the operation returns the value of the variable before incrementing it. Note that plus plus operator can be used in the middle of a long and complicated expression. Example, I is equal to j times plus plus k minus 23. The operators are all shorthand versions of assignment statements that are used to change the value of a variable. The statement variable plus equals expression adds the value of expression to variable. Similarly, variable minus equals expression, variable times equals expression, variable divide by equals expression, subtracts expression from variable, multiplies variable by expression, and divides variable by expression, respectively. The unary operators plus plus and minus minus are used to increment and decrement value variables, respectively. Both can be used in prefix or postfix form. In other words, before or after the variable that they change. The pre and postfix forms have the same effect on the variable. The difference lies in the value that they return when used in an expression or as an expression. The prefix form returns the value of the variable after it has been changed, whereas the postfix form returns its value before it was changed. Important points in this lesson. Programming concepts. We can change the value of a variable in two ways. Firstly, As we saw in the previous lesson, we can input a value into a variable using a cin statement. Secondly, as we saw in this lesson, we can assign a value to the variable using an assignment statement. The general format of an assignment statement is variable equals expression. The value of expression is calculated first, and then the result is stored in variable. Expression may therefore contain one or more occurrences of variable. In such a case, the old value of variable is used to calculate expression, and the result is stored back in variable. Then we learnt about the so-called compound assignment operators, namely plus, minus. They provide a shorthand notation for assignment statements for changing the value of a variable. In such a case, the old value variable is used to calculate expression, and the result is stored back in variable. Then we learnt about the so-called compound assignment operators, namely they provide a shorthand notation for assignment statements for changing the value of a variable. For example, variable expression subtracts the value of expression from variable. Finally, we saw the two unary operators plus plus and minus minus. Add 1 and subtract 1 from the variable they are applied to respectively. Plus plus is called unary increment operator, and minus minus is called unary decrement operator. We saw that these operators, together with the variable they are operating on, return a value. They can therefore be used where an expression is required or in a longer complicated expression. The value returned by such an expression depends on whether the operator is used before the variable prefix form or after it postfix form. If the operator is used before it, the return value is the final change value of the variable, whereas if it is used after it, the return value is the original value of the variable, in other words, before it was changed. Programming principles. We saw the following tips and tricks to make programs more readable and less prone to errors. Use numeric digits in variable names to distinguish different variables that are used to store the same kind of values. Remember to initialize variables, either by assigning a value to them or by inputting a value for them before using them. Rather declare additional variables than do calculations in an input statement. If you find you're doing exactly the same calculation over and over, declare a variable and store the results of the calculation once in it. Exercises. Exercise 4.1. Redo exercise 3.3, but use a variable to store the results of the calculation instead of doing the calculation in the input statement, in the output statement. Exercise 4.2. Sam is a small business which does packaging and posting. Clients come to him with a number of items of the same size and shape, and he has to pack them into boxes before posting them to some customer of theirs. He works as follows. He packs as many of the items in a box as he can and then calculates how many boxes he will need and how many items will be left over. In other words, that won't fit into a box. Write a program to input a number of items and a number of items that fit into a box. The program should calculate how many boxes will be needed and how many items will be left over. Exercise 4.3. What will the value of variable n be after the following series of statements? Int n equals 10. N plus equals 3. N divided by equals 2. N plus plus, n modulate operator 4. N minus equals 5.